Good morning students, welcome to GOUTAM'S classes. Today we are with exercise 4.1 from class 10 NCERT mathematics book. In exercise 4.1, question number 1 has 8 bits, 8 equations are given there. What is the instruction? Instruction of the question is to check whether the given equations are quadratic equations or not. If the given equations are quadratic equations, we shall tell yes it is quadratic, otherwise not. So whatever the equations are given, we will simplify them to the simplified step and then we shall declare whether it is quadratic or not. We shall see the last step, the last simplified step, whether that step is in the form of ax square plus bx plus c is equal to 0 or not. You know the standard form ax square plus bx plus c tells that a, b, c are real numbers, a is not equal to 0, a should not be 0. The coefficient of x square should not be 0. And x is variable here. So let us start question number 1. Question number 1 I tells that x plus 1 whole square is equal to 2 into x minus 3. Let us simplify it. This x plus 1 whole square, this falls under identity. A plus b whole square equals to a square plus 2ab plus b square. Identify who is a and who is b here. In place of a we have x here, is that? And in place of b we have 1. So I will write now a square plus 2ab plus b square. X plus 1 whole square matches with a plus b whole square. I am going to write in this step a square plus 2ab plus b square in place of x plus 1 whole square. Who is a? X. So in place of a square I'll write x square plus 2ab. Who is a? X. Who is b? 1 plus b square. Who is b? 1. So 1 square. On right side, 2 is multiplied with x minus 3. By distributive property, 2 is getting multiplied with x, 2 will get multiplied with minus 3 also. So 2 into x gives you 2x and 2 into minus 3 gives you minus 6. Now, what you have? X square. Square of x is x square. 2 into x into 1. 2 into 1 is 2 and x. You have 2x plus 1 square is 1. On right side now, as we have already 2x minus 6, I am copying that. Now, in this step, what we shall do, let me shift everything from right side to left side. I have x square plus 2x plus 1 on left side already. 2x minus 6 comes to left side. 2x will become minus 2x and minus 6 will become plus 6. What do we have on right side? On right side we have 0. Now, closely observe the like terms now. X square doesn't have any like term in whole LHS. So I am copying x square. 2x has a like term. Minus 2x I have also. So plus 2x minus 2x will cancel each other. Two like terms exactly having the same things except the symbols. You can cancel them. Okay. So plus 2x and minus 2x only differ from each other by symbols. So they will get cancelled. In other words, plus 2x minus 2x gives you 0. So they are out. Now plus 1 and plus 6. These two are also like terms. Constant terms are like terms. So plus 1 plus 6 gives you plus 7 equals 0. We cannot simplify anymore. Will you be able to simplify anymore? No, it's not possible. So here we end up with our last step. Now we have to decide whether it is quadratic or not. As I said, according to our standard form, the coefficient of x square should not be 0. However, for b and c, the coefficients b and c are real numbers. There is no specification about b and c whether they are 0 or not. There is no specification. They can be 0, they may not be 0. So here, if I want, I can express this in standard form. You can see coefficient of x square is not 0, it's 1 here. So I can write 1 into x square. 1 is coefficient of x square plus the term bx is not present here. You can see the term with x is not there. So for b I can take 0. Probably 0 was the value of b and x was their variable, because of which the multiplication of x and 0 gives you 0. The term is out. That's why you don't find the term with bx in this step. Now plus c. C is the constant term. What is the constant term here? Plus 7. So 7 is c. I am writing that equals to 0. Now you can check it clearly. It is telling ax square plus bx plus c equals to 0. So we were able to express this particular step, simplified step, in the form of ax square plus bx plus c is equal to 0. That's why this equation is a quadratic equation. So we shall declare that it is in the form of ax square plus bx plus c equals 0. So it is a quadratic equation. You can answer also if anyone asks you what is the value of a, b and c. A is 1, b is 0 and c is 7. Isn't it good? By the way, if you want to write at the end of this step directly without expressing this step in the form of ax square plus bx plus c is equal to 0, if you want to directly write it is a quadratic equation after this step immediately, there is no problem. It is also understood. This will be also your right answer. And if you express it in this form and then explain this statement, then you write, it is also okay. Let's move on to question number 2. Here what do you have? X square minus 2x is equal to minus 2 into 3 minus x. Let me simplify for you. Left side is already simplified, you can see. I can write it as it is. Right side, again by distributive property, I shall multiply minus 2 with 3 minus 2 with minus x. Minus 2 into 3 gives you minus 6. Minus 2 into minus x. Minus into minus plus 2 into x, you get 2x. Now, right side and left side simplified independently, I will say individually. Let me shift everything from right to left now. X square minus 2x, minus 6 comes to this side, becomes plus 6, plus 2x becomes minus 2x on left side, equals right side is 0. Now, watch for, let's look for like terms. X square doesn't have any like term, you can see. There is no term having x square, no. So, copy that. Minus 2x has a like term, minus 2x again. So, here you can see both the terms are like terms. They are completely identical. Symbols are even same. If symbols are opposite, then they could be cancelled here. But symbols are also same. In case the symbols are same, we carry out addition of the coefficients. 2 plus 2 gives you 4 with same symbol. Remember, with this minus symbol. Some students think minus into minus, minus minus becomes plus. That is in case of multiplication, not in case of addition. Here, the symbols remains the same. Minus symbol will be kept, not plus. Not plus. 2 plus 2 gives you 4. And x plus 6 is left. Don't forget. This is the simplified step. You cannot simplify anymore. Now you can directly write, as I said, that it is a quadratic equation. Otherwise, you can express in the form of ax square plus bx plus c is equal to 0. Already it is little more simplified. Let me show you here. 1 is the coefficient of x. So 1x square plus is there, so I copied plus bx. B stands for minus 4. Plus into minus will get you minus 4 back when you multiply them. Okay, and x is there. Plus again because plus is here, so plus is here. Who is c? This value 6 equals 0. Now it is in the form of ax square plus bx plus c equals to 0. You are clear? So we were able to express here also in the form of ax square plus bx plus c is equal to 0. Everywhere we will try to express the final step, the simplified step in this form, ax square plus bx plus c is equal to 0, and we shall declare. So here it is in the form of ax square plus bx plus c equals to 0. So the equation is quadratic. Okay, let's move on to triple I. Here you have x minus 2 multiplied with x plus 1, and then on right side you have x minus 1 multiplied with x plus 3. So on left side, let me multiply first by using distributive property. Okay, When you have two linear expressions multiplied or two expressions multiplied with each other, then all the terms of one expression will get multiplied with all the terms of the other expression by distributive property. So x multiplied with x, x multiplied with 1, minus 2 multiplied with x, minus 2 multiplied with 1. X into x gives you x square, x into 1 gives you plus x, minus 2 into x gives you minus 2x, and minus 2 into plus 1, minus into plus, minus 2 into 1 is 2. Similarly on right side, again two expressions are getting multiplied. All the terms of this expression will get multiplied with all the terms of this. X multiplied with x, x multiplied with 3, x multiplied with x, x square, x multiplied with 3, 3x. Are you clear? Let's continue. Minus 1 into x is minus x, and minus 1 into plus 3 is minus 3. Now this part is clear. Have a look now what we shall do. I can shift all the things from right side to left side, but let me write one more step to simplify LHS and RHS individually. Here like terms x and minus 2x are there. I will work with them. X square has no like term, I copied it. Plus x minus 2x, like terms, they are like terms. Here coefficient of x is 1 and it is minus 2, coefficient of x. Plus 1 minus 2, plus 1 minus 2 gives you minus 1. So minus 1x or simply minus x, and minus 2 is there, copy it. On right side similarly x square has no like term, but 3x and x are like terms. These two terms are like terms. 3x minus x, simply 2x. Okay, two like terms, if they have the same symbol, remember they will be added, means their coefficients will be added. Like here we had two like terms, had same symbols, so their coefficients 2 plus 2 we added and we wrote with the same symbol, keeping the same symbol, minus 4x. But here the like terms do not have the same symbol. In case the terms do not have same symbol, the like terms do not have same symbol, your work is to subtract from bigger the smaller one. 3 minus 1 gives you 2, and keep the symbol of the bigger number. 3 is bigger, so plus symbol has been kept here. Here 2 was bigger, so minus symbol has been kept here, and difference of 2 and 1 is 1, so 1x. But here 3 is bigger, so plus symbol has been kept. 3 minus 1 is 2, so 2x. Now minus 3 was there. Let me shift everything from right side to left side now. X square minus x minus 2 are already there, plus x square becomes minus x square, plus 2x becomes minus 2x, and minus 3 becomes plus 3 equals 0. Now you can see this is x square, plus x square and minus x square, they will cancel each other. Two like terms exactly same except the symbols will get cancel each other. How? That is also according to subtraction, addition subtraction rules. This is positive, this is negative. Coefficient is plus 1, here minus 1. So in case opposite symbols are there, we subtract. So plus 1 minus 1 gives you 0. That's why the value of these two is 0. So we cancel them. Minus x minus 2x gives you minus 3x, and minus 2 plus 3 gives you plus 1. How it is? Minus x and minus 2x are like terms. So minus 1 is coefficient, here minus 2 is coefficient. They both have the same symbol. So addition of coefficients will be there. Minus symbol has been kept, the same symbol, and 1 and 2 gives you 3 together. So minus 3x. But here minus 2 and plus 3, these two are constant terms. So they are like terms. Opposite symbols are there, that's why I have to keep the symbol of the bigger, means plus. And difference 3 and 2. The difference of 3 and 2 is 1. So I have plus 1. Now it gives you 0. This is the simplified step here. In the simplified step now, let's check whether we can express this as ax square plus bx plus c is equal to 0 or not. You can see that the term with x is there, but the term with x square is missing. Ax square, the term with ax square is not there. So I can say that the value of a is 0 here. And this is b is minus 3 and x and plus 1 equals to 0. So when I try to express it in standard form, this expression is now violating the standard form ax square plus bx plus c is equal to 0. I was able to express in the form of 0 into x square plus minus 3 into x plus 1, but see the conditions, a should not be 0. A is not equal to 0. A is not equal to 0. See this condition. But here you find A is equal to 0. So this is not in standard form. This is not in standard form. This is not in standard form. Ax square plus bx plus c equals to 0. Here A is equal to 0. So this is not a quadratic equation. Okay. According to standard form of quadratic equation, A should not be 0. But we have A is 0. Here A is 0. That's why it is not a quadratic equation. Right? Well, this is not in standard form. Ax square plus bx plus c is equal to 0 as A is equal to 0. Okay. Let me write as A is equal to 0. So this is not a quadratic equation. That's clear. Now let's move on to the next questions of this question number 1. So students, I have now question number IV, V and VI. Basically, in all these numbers, we are using Bodmas rule, distributive property or identities. We are simplifying the left hand side and right hand side of the equation. We are shifting from right side everything to left side, then getting a simplified step. If that is a quadratic equation, we are declaring yes, the equation is quadratic. If the final step, the simplified step is not in the form of ax square plus bx plus c is equal to 0, then we are telling it is not a quadratic equation. That's all. Let's start IV. Here again by distributive property I can multiply x with 2x, x with 1, minus 3 with 2x, minus 3 with 1. X with 2x, x into 2x gives you 2x square. X with 1, x into plus 1 gives you plus x. Minus 3 into 2x gives you minus 6x. Minus 3 into plus 1 gives you minus 3. On right side, again distributive property, x into x and x into 5. X into x is x square, x into 5 is 5x. I can add these two in this step, add or subtract these two like terms, but let me directly take everything from right side to left. There is no issue. 2x square plus x minus 6x minus 3 plus x square comes to this side becomes minus x square plus 5x comes to this side becomes minus 5x. On right side you have now 0. Some students while doing all this forget to write right side also. Please don't try to commit that kind of mistake. Keep on writing LHS, RHS both together in every step. And don't forget to put implies that symbol. This is a good presentation. 2x square has a like term minus x square on left side now. 2x square has coefficient plus 2 and minus x square has coefficient minus 1. Plus 2 minus 1 gives you plus 1. In other words, 2x square minus x square is x square. 1x square that is. Plus x minus 6x and minus 5x. These three are like terms. They all have the variable x with power 1. So they are like terms. This is plus 1, coefficient is plus 1, here minus 6 and here minus 5. Plus 1 minus 6 gives you, and we have minus 5. Plus 1 minus 6 gives you minus 5 and again minus 5. So you get minus 10. So minus 10x. And then this constant term is with us. Don't forget that. Minus 3 is there. Now, is it the simplified step? Yes, this is the simplified step. Let us compare it with the standard form ax square plus bx plus c is equal to 0. Does it follow? Yes. You can see the coefficient of x square is not 0, it's 1. And then plus, let me copy from standard form. Who is b then? Minus 10. Minus 10 upon multiplication with plus will give you minus 10 only. Then x. So plus bx plus c. Who is c? Minus 3 itself. Okay. Some students, when teachers ask them what is a, b and c, sometimes they say only 3. It's not only 3, it's minus 3. Tell with the symbol. Okay. Who is b? Minus 10. Who is a? 1. Is that clear? Now, this is following the standard forms. So we can declare this is a quadratic equation. Let me write. It is in the form of ax square plus bx plus c equals to 0. So the equation is quadratic. The equation is quadratic. So the equation is quadratic equation. Is that clear? Now come to number v. Here what we have? We have again two expressions getting multiplied on each side. So by distributive property, let me multiply. 2x into x gives you 2x square. 2x into minus 3 gives you minus 6x. And minus 1 with x gives you minus x. And minus 1 with minus 3 gives you plus 3. I am multiplying. So minus into minus becomes plus. 1 into 3 is 3. On right side similarly, x into x, x into minus 1, x into x is x square, x into minus 1 is minus x, 5 into x is plus 5x, and 5 into minus 1 is minus 5. That's it. Now, in this step, on each side, let me again simplify by adding or subtracting like terms. I have 2x square, minus 6x and minus x, they are like terms. So it gives you minus 7x plus 3. On right side, I have x square, minus x plus 5x. It gives you plus 4x. Negative, positive. Opposite symbols are there, so subtraction of coefficients will be there. 5 minus 1 gives you 4. Symbol of the bigger, plus, and x. Now, if I transfer everything from right to left, they will change their symbols. 2x square minus 7x plus 3 plus x square comes to left side becomes minus x square, plus 4x becomes minus 4x, minus 5 becomes plus 5. While shifting from right to left, sometimes students forget to change the symbols. Be careful about that. You have to have focus while solving mathematics questions. Okay, even if you make a simple mistake of changing symbol, while changing symbol, if you forget to change symbols while shifting from right to left, then the whole answer becomes wrong. The next steps will become wrong. So that's why be careful. Now I have like terms 2x square with minus x square. 2x square minus x square gives you x square. Minus 7x minus 4x is minus 11x plus 3 and plus 5. This will give you plus 8 equals 0. This is the simplified step. Declare whether it is quadratic or not. I can express it in terms of ax square plus bx plus c. So here 1 is a, x square I have, plus b is minus 11, x is there, plus c is 8. C is equal to 8. This is in standard form now. So this was our equation. We expressed it in standard form. Now you can see this matches exactly with this, following the conditions. Okay. This is in the form of ax square plus bx plus c equals to 0. So this is a quadratic equation. Alright, let's move on to 6th number, vi. Here the left hand side is already simplified. You can see x square plus 3x plus 1. No more addition, subtraction or multiplication, nothing is left here. Let me copy. But on right side you see I have x minus 2 whole square. It matches with our identity a minus b whole square equals to a square minus 2ab plus b square. So this part falls under this identity. It matches with left hand side of this particular identity. So we will write the right hand side here. In place of x minus 2 whole square, we will try to write this form. Is that clear? So a, in place of a we have x, in place of b we have 2. Now I will write a square minus 2ab plus b square, taking x as a and 2 as b. So a square means square of x minus 2ab. Who is a? As I said, x. So this is here. And who is b? 2, not minus 2. Remember, this minus symbol, if you're thinking you should write here, no, you don't have to write, because this minus is already taken here. This minus has come because of this. Okay, so you don't have to write here minus 2, only write 2. In place of b, you have 2. Now, plus b square. You are taking b as a 2, so 2 square. Okay. Now, in the next step, we have x square plus 3x plus 1 equals square of x is x square minus 2 into x into 2. Minus 2 into 2 gives you minus 4, and x plus 2 square is 4. Let me shift everything from right side to left now. X square plus 3x plus 1 plus x square comes to this side, becomes minus x square, minus 4x becomes plus 4x, plus 4 becomes minus 4 equals to 0. Any like terms? Yes, x square and minus x square. They will cancel each other. Don't you see that? Here plus 1 is the coefficient, here minus 1 is the coefficient. Both are like terms. So, in other words, the two terms are like terms, having everything same except the symbol. So, you cancel them. This gives you 0. 3x and 4x are like terms. So, plus 3 plus 4 becomes 7x. Plus 1 and minus 4 are constant terms. Let me add them or subtract them according to their symbols. Plus, it is minus. Bigger is 4, so symbol of 4 will be given, minus, and subtraction will be there. 4 minus 3 is 1 is equal to 0. This is a simplified step of this particular question. Do you see it is falling under this particular condition? Ax square plus bx plus c is equal to 0? No. You can say that this is a degree 1 polynomial. It's a linear polynomial. So, this is not a quadratic equation. You can directly write that also. The equation on the left is, the polynomial on the left is a linear one. So, it is not a quadratic equation. Or you can express, as we are doing in all the cases, we are trying to express this as a quadratic equation. If not, we are saying it is not. If it is yes, then we are saying it is a quadratic equation. If I try to express, it will be like 0 into x square plus 7 into x plus minus 1 equals to 0. When I try to express that last simplified step in the form of x square plus bx plus c is equal to 0, you see what happened. When I wrote x square, the coefficient of x square is 0. 0 into x square gives you 0. That's why the term is missing here. Okay, so I have to take in place of a 0. That's why, because of that, I took 0 for a. Clear? So this is going against our conditions. Our conditions were a is not equal to 0, but here a is equal to 0. So this is not in standard form. It is not in the standard form. Ax square plus b plus c equals to 0, as in the simplified step a is equal to 0. So it is not a quadratic equation. So this is not a quadratic equation. Hope it is clear. Let's move on to the last two bits, viii and viii. In these two questions, also we will try to express the equations in the quadratic equation form. Okay, in the standard form of quadratic equation. Here what we have x plus 2 whole cube. It falls under the identity a plus b whole cube. A plus b whole cube equals to, we have a cube plus 3a square b plus 3ab square plus b cube. This is identity of a plus b whole cube. So this particular part, x plus 2 whole cube, matches with left hand side of our identity. We will try to expand it. Expansion of x plus 2 whole cube will be done here. Expansion of a plus b whole cube tells you a cube plus 3a square b plus 3ab square plus b cube. So in place of x plus 2 whole cube, we will try to express this part now. Who is playing the role of a? A is here. Who is a here? X. In place of b, we have 2 here. So while writing this part for this, we will write in place of a x. So a cube means cube of x plus 3a square b. A square means square of x, and b, as I said, b means 2. So 3a square b plus 3ab square. Who is a? X. So let me write x, and b square. 2 is playing the role of b. So 2 square plus I have b cube. B means 2. So again 2 cube equals, on the right side you have 2 with x square, 2x with x square and 2x with minus 1 by distributive property. 2x will get multiplied with x square minus 1 by distributive property. 2x into x square gives you 2x cube. How? Power of x is 1, power of x is 2 here. 2 plus 1 gives you 3. When you multiply the same variables, their powers get added. 2 plus 1 will give you 3. So 2x into x square gives you 2x cube. 2x into minus 1 gives you 2x minus 2x. 2x into minus 1 is minus 2x. Now let me simplify it a little more. Cube of x is x cube. 3 into 2 gives you 6, and x square. Square of x is x square. Now plus 3 into 2 square gives you 12. 2 square is 4. 4 gets multiplied with 3. So you get 12. 4 3s are 12. And x. Sometimes students multiply 3 with 2 first. 3 into 2 gives you 6. And square of 6 is 36. That is wrong. You have to first calculate the square of 2. Then multiply with 3. Okay. So 3 into 2 square means 2 square is 4. 4 into 3 gives you 12, and then x. This is right process. Don't multiply 2 and 3 first when 2 already has a power. First calculate what is power of 2. Means 2 square we have, so 2 square is 4. 4 into 3 gives you 12, and x. You have 12x. 2 cube is 8 equals, we have 2x cube minus 2x. Up to this it is clear. Now we will shift everything from right to left. On shifting everything from right to left, we have x cube plus 6x square plus 12x plus 8. 2x cube from right to left when comes, we have minus 2x cube. Minus 2x becomes plus 2x equals 0. On right side you have 0. Now search for like terms. X cube and minus 2x cube are like terms. So their coefficients, let's see, plus 1, minus 2. Bigger is 2, so symbol will be minus, because symbol of 2 is minus. And subtraction of the coefficients, 2 and the 1, the numeral part, 2 and 1, the difference is 1. 1x cube, or simply x cube. 1x cube or x cube. Now 6x square has any like term? No. So let me copy that as it is. 12x has like terms? Yes. 12x plus 2x, both are positive, so there will be addition. Plus 14x. And plus 8 is the only constant term here. So let me copy. Now, this is the simplified step. You cannot add or subtract anymore. Okay. Have a look at this polynomial now. Is it quadratic? The degree of this polynomial is 3. Okay. You see the highest power of the variable involved is 3. So it is a cubic polynomial, not a quadratic polynomial. Okay. You can declare directly that this is not a quadratic polynomial. If you want to express it also, there is no problem. You can write it like a is minus 1 and x cube plus 6 is b and this is x square plus 14 is c and this is x, and another term comes d. So we have a x cube plus b x square plus cx plus d is equal to 0. Actually this is standard form of cubic polynomial, cubic equation. So this is not a quadratic equation. You can declare that this particular step, this simplified step of this number is not matching with standard form of quadratic equation. So this is not quadratic equation. I will write here. This is not in the form of ax square plus bx plus c equals to 0. So this is not a quadratic equation. Alright, this is clear. Now let's go for to VIII. In VIII, what we have? X cube minus 4x square minus x plus 1 is equal to x minus 2 whole cube. Left hand side, as you can see, it is clear. Left hand side is simplified already. There is no like term, no addition, subtraction is left to do. So we have same thing on right side, but you have x minus 2 whole cube. It comes under identity a minus b whole cube. A minus b whole cube tells that a cube minus 3a square b plus 3ab square minus b cube. Okay. In the previous question, in the previous bit VII, we used a plus b whole cube. Now we are going to use here a minus b whole cube. You can easily remember these identities after using it many times in different questions. Also, you get a practice and you remember it very easily. But instantly, if you want to remember them also, there is no problem. If you observe the pattern, see, a plus b whole cube is a cube plus 3a square b plus 3ab square and plus b cube, whereas a minus b whole cube is a cube minus 3a square b plus 3ab square minus b cube. Do you find a pattern? Yes. In both the identities, you have a cube, b cube, 3a square b, 3ab square. And in case of a plus b whole cube, you have every term positive. In case of a minus b whole cube, you have the terms having symbols alternately, plus minus, plus minus. Okay, a cube minus 3a square b, then plus 3ab square minus b cube. I will try to express x minus 2 whole cube in this form now. Okay, I'll expand it. So expansion will give me this part. But who is in place of a? X. So a cube means, I'll write x cube, then minus 3a square b means minus 3, a square means square of x, and b is 2. Then I have plus 3ab square. So I will write that 3a means x, b square means square of 2. Then I have minus b cube. So minus 2 is in place of a b. So I have minus 2 cube. Let me simplify in the next step again. Well, up to this it is clear. You see, x cube minus 4x square minus x plus 1 equals cube of x is x cube minus 3 into 2 gives you minus 6, square of x is x square, plus 3 into 2 square is 4, so plus 3 into 4 is plus 12, and x, then we have minus 2 cube is 8. While multiplying, make sure that you multiply the symbols first. For example, I am multiplying here 3x square and 2. Minus into plus is minus. Then multiply the coefficients or the numbers, the numerical parts. 3 and 2 gives you 6. Then variables, square of x is x square. Okay. Similarly here also, plus 3, first plus into plus, I multiplied symbols. Then multiply numericals. 3 into 2 square. 2 square is 4. 4 into 3 is 12. Then go for the variables. Only variable is x, copy that. So we multiply symbols, then the numbers, then the variables while multiplying. Okay, make sure that. Now this is 2 cube is 8. This is time now when I shift everything from right to left. X cube minus 4x square minus x plus 1. X cube from right side comes to left side, becomes minus x cube, minus 6x square becomes plus 6x square, and plus 12x becomes minus 12x, and minus 8 becomes plus 8. Don't make mistakes while changing the symbols when you shift from right to left. Be careful. Now let us see for the like terms. X cube, yes, there is a like term, plus x cube minus x cube gets cancelled. Because the two terms are like terms, everything is same except the symbols. Cancel them, they give you 0. Now minus 4x square and plus 6x square I have, they are like terms. Opposite symbols are there, so subtraction will be there, and symbol of the bigger number will be used. Symbol of the bigger number is plus, so plus I will use. And the difference of 6 and 4 is 2. 2x square. This is plus 2x square. Now minus 6 and minus 12x, these two are like terms. They both have same symbols. So there will be addition of the coefficients. 12 and 1 will give you 13. Copy the variable. Now what are the constant parts left? Plus 1 and plus 8. 1 plus 8 gives you 9. Now this is the simplified step of this particular bit viii. So compare this with standard form ax square plus bx plus c is equal to 0. Is it coming under that? Yes, it is. You can see the polynomial on the left side is having degree 2. The highest power of the variable is 2 here. So this is a quadratic polynomial. I can express it also in the form of x square plus bx plus c as 2 into x square plus who is b minus 13 and x plus 8 is playing the role of c. Ax square plus bx plus c. So this is in the form of ax square plus bx plus c equals 0. So this is a quadratic equation. This is a quadratic equation. Hope it is clear to you all. So we end with question number 1 here. It is over. At the same time, I must tell, here we did many things. We applied identities. We multiplied ways using distributive property. We were simplifying left and right side both simultaneously, and when both were simplified, we were shifting from right side everything to left side. Then upon addition subtraction, finally on left side we were having a simplified expression having unlike terms only. Means no like terms are left, no addition subtraction is possible. And on right side we everywhere had 0. And we tried to compare with standard form of quadratic equation. If it was found matching with the standard form, we said it is a quadratic equation, otherwise not. This kind of questions generally come in MCQ part by asking you, check which of the following is a quadratic equation. Out of I to viii, any 4 equations or any different kind of equation may be given to you in the 4 options, and you have to select out of them which is a quadratic equation, or it may be asked also which is not a quadratic equation. So you can check that. Sometimes students use some smarter ways. They check for the degree directly without solving this all, without doing all these steps. They check for, suppose x cube is there. For example, I am picking up viii. They check for x cube. On left side they have x cube. On right side, do they have x cube? They check for that. Yes, upon simplifying this, they will get x cube. So x cube when comes to left, it will get cancelled. So x cube is out. Is 4x square, the term with x square is existing? Because existence of a term with x square is important. It will give you quadratic equation. So minus 4x square we have. On that side also they are going to, the student is going to get x square when he will have 3a square b minus 3 into a square means x square, and b is 2. So it gives minus 6x square. When it comes to this side, becomes plus 6x square. So plus 6x square minus 4x square, they calculate mentally. It's not giving 0. So a term with x square will be left. The coefficient of the term with x square will not be 0. So they decided by thinking this is a quadratic equation. Okay. So this saves their time. Instead of solving step by step, which takes a little more time, they can think just for 10 to 20 seconds or 30 seconds, and they can decide that this is a quadratic equation. Okay. Let's move on to our next number in this particular exercise 4.1, number 2.